So the topic of this video is to discuss dimensional analysis. I know that dimensional analysis is a topic that can be challenging for some students, but I promise there are two simple tricks I'm going to teach you here that are going to make it easy for you to answer any dimensional analysis problem that you come across. The first one is that you use the problem to get the units for your answer. So in this simple problem, we're looking at how many seconds there are in one day. So that tells us the units for our answer are going to be written in seconds per day. So we're going to write that one down first. So we'll have seconds on the top and then day at the bottom. So the next thing for you to do is to figure out a simple breakdown where you'd have day on the bottom, like and the denominator of one of your simple elements for dimensional analysis. So one, it's easy to start with, that everybody knows, is that there are 24 hours in one day. So now we've got day down on the bottom portion, which is exactly what we're looking for in our answer. The second part, and this is really the key to dimensional analysis, if you just remember, what goes up must come down. So whatever is in the numerator of one of these problems has to be in the denominator of the next one. So we need something now that has hours down in the denominator. So an easy one to go with here is we have 60 minutes in 1 hour. What this is going to allow us to do is to cancel out those units since they're on opposite sides of each other. So the next one for us to look at is we need minutes, because remember, what goes up must come down. So now we need minutes in the denominator of the next one. So here we'd end up with 60 seconds in 1 minute. So again, since we end up with minutes on opposite sides, we can cross those out. Now if you look carefully, what we're left with are seconds in the numerator and days in the denominator. We wrote that one down in the very beginning. That's what we want. That's going to be the breakdown for our answer. So what you end up doing then, for this one it's easy. Since all of our numbers are in the numerator, you just multiply each of these together. If you had a number other than 1 down here, you would then have to multiply each of these together, multiply each of these together, and then divide your top number by your bottom number. But since we have only ones in the bottom, all we have to do is multiply 24 times 60 times 60 again, which comes out to quite a few. We end up with 86,400 seconds per day. You can use dimensional analysis to break down any kind of problem like that. Again, the two important things to remember is once you read the problem, you've got to figure out what the units are that your answer is going to be in, and then if you just remember what goes up must come down, what goes up must come down, that's going to keep crossing out the appropriate units for you, and you'll eventually work your way to the answer to the problem. So we'll take a look at one for the next example that's a little bit more complex, but maybe also a little bit more practical. So in this example, you're trying to figure out how many pizzas you need if you're having 5 friends over, and each friend is going to eat 4 slices of pizza. So I added in an extra little piece of information for you. There's 8 slices to each pizza. So to start off, now I'm going to shrink this down just a little bit. We'll blow it up again if we need it, but sort of shrink that down and put it up in the corner to give us some room. Like I said to you before, the first step is to figure out the units for your answers. So we're trying to figure out, how many pizzas are we going to need? So that's going to be our answer. To start off, we just have to go through and begin this problem. We said up here in the beginning that we're going to have 5 friends over. So we'll start off with that since that's the first piece of information in the problem. So we'll say there's 5 people. Now, this is a good example of one where you don't always need something in the bottom. We're just going to leave the 5 people up there by themselves for now. The next step, the next piece of information that we have in the problem is that each friend is going to eat 4 slices of pizza. So we'll put that one in. So we've got 4 slices for each person. So people and person. Those cross out. I know it's not exactly the same word, but we've got, we're basically just going from like plural to singular, right? 4 slices for each person, 5 total people. It's still the same kind of units. So we're crossing them out with that whole idea of what goes up must come down. Those two have to be opposites, and they've got to cross off from one another. The next piece of information in the problem tells us there's 8 slices to each pizza. This is good. Pizza is the unit that we're trying to end with. So we'll put pizza on the top here, since we need to end with pizzas. 1 pizza has 8 slices. So now if you look, we can cross out slices. Now this problem becomes a little bit more complicated. If we're looking at this, we've got to go 5 times 4. So that one ends up giving us 20. I'm just going to write this up here at the top. And then we've got 20 divided by 8. So since we're looking at ordering whole pizzas for the party, and since pizza, is the only unit that we have left up here, everything else has been crossed out, 8 doesn't go into 20 evenly. But if you only bought 2 pizzas, for example, that would give you 16 slices of pizza. That wouldn't be enough for all of your friends. So in this case, we have to go up to like the next highest number. So if we were to order 3 pizzas, that would give us 24 slices. That at least gets you to your minimum of 20. So in order to have enough pizza for all of your friends, you would ultimately need to order 3. You have to order 3 pizzas in order to make sure everybody has enough. Now, hopefully everybody sticks to what they said, right? And they only eat their 4 slices of pizza, but that we can't necessarily control. But this should give you an idea of if you follow those 2 simple steps that I said. The first thing is to just figure out your units. What are you solving for? And then the second thing is that idea of what goes up must come down. To cross out those units, these dimensional analysis problems actually become really simple. So I'm trying to show you with this particular example that they can also sometimes be practical. It's not always just trying to convert, miles per hour to feet per second or something like that. There are elements of this that are actually very practical that you could use in your everyday life. So hopefully this makes dimensional analysis a little bit easier and maybe even a little bit more fun for you. Thanks for watching.